So we're going to talk about side and angle relationships in triangles. So we're going to start with actually kind of doing the example. So for below, list the angles in order from least to greatest. So before I talk about this, one of the things I want to make sure you guys understand is the concept of an opposite side. And it's basically the side that doesn't make up the angle. And this is going to come into play a little bit later in the year. So if I'm talking about this angle, this is going to be the opposite side for this angle. Actually, one of the things that's actually kind of interesting is if I said that this is angle A, say this is ABC, this would be side A. Okay, if I were talking about this angle right here, this side would be opposite, and so that would have to be side C. And if I were talking about this angle here, this would be the opposite side, so I would label that little b. Okay, so when I talk about opposite sides, that's what I'm talking about. Okay, so for below, list the angles from least to greatest. So when I'm doing a problem like this, if I'm listing the angles from least to greatest, well, actually that has a direct relationship with the sides, because basically the smaller the side, the smaller the opposite, or the smaller of the side, the smaller the opposite angle. So in this triangle, my smallest side is this 6 centimeters, so I know T has to be the smallest angle. So one of the things I like to do with these questions is I actually will order the sides from least to greatest, so 6 centimeters, then 7 centimeters, then 9 centimeters, and then I write the angles in that same order that are opposite those sides. So my smallest angle must be angle T. Then my next angle would be angle R, and my last angle would be angle S. So T, R, and S. So basically what that just is indicating is that the larger the angle, the larger the opposite side. Okay. We're going to look at the next one. Now we're asking to list the sides from shortest to longest. Well, you can kind of see visually that this looks to be the shortest side, and you'd be right because it would be opposite the 20-degree angle. So again, the reverse is true. Actually, I wrote the larger the angle, larger the opposite side. This one right here is the larger the opposite side, the larger the angle. Okay, so my 20, so what I would do if I were ordering the sides is I'd start with my 20-degree angle, and then I would go to my 35-degree angle, then I would go to my 125-degree angle. Those would be my angles from lowest to highest. Now, since BC is opposite, BC is going to be my smallest side, opposite my smallest angle. The 35 here, well, the side opposite of that is AB. And lastly is this 125-degree side, which is opposite AC. Let's just do a few example problems. So my next one is ADB, this angle here, well, that's opposite my 10, okay, and angle DBA. So we're comparing these. Well, I know ADB is opposite the 10, and DBA is opposite the 8, and since I know 10 is greater than 8, the measure of angle ADB must be greater than the measure of angle DBA. Okay, so the other one is CDA, this whole angle here, and the other one is CBA, this whole angle here. So that one's a little bit trickier, but what I want you to remember is this angle here was larger than this angle here, right? So right now, ADC is winning. Now the other thing I look at is angle CDB, the other part of the angle, angle CDB, and angle CBD, this part right here. So which one's bigger here? Well, in this case, this angle right here, well, it's opposite the 15. This angle here is opposite the 16. I know 15 is less than 16. So basically, I just showed that this angle is bigger than this angle. This angle is bigger than this angle. So the whole angle must be bigger than the whole angle. So angle CDA must be greater than, the measure of CDA must be greater than the measure of angle CBA, if the angles that make them up are larger. All right, next thing is AE and EB. So AE is opposite this angle, and EB is opposite the 110. AE is opposite the 30. EB is opposite the 110. 30 is less than 110, so the distance from A to E, and when I write distance, I don't put the segment bar over it, is less than the distance from E to B. Okay, next one. CE, and then we're talking about CD. Okay, CE, well, we need to find that measure, so that's going to be 180 minus 50 minus 55, which is 75 degrees. So CE, the angle opposite CE, is 75 degrees. The angle opposite CD, this one right here, or the side opposites, sorry, CD is 55 degrees. I know 75 is greater than 55, so CE, the distance from C to E, must be greater than the distance from C to D. All right, last but not least, this one right here. We have BC and EC, and it's within this triangle. BC is opposite this angle. I do the same thing. I do 180 minus 40 minus 100. This ends up being 40 degrees. EC, so that was EC, sorry. The opposite angle opposite, EC is also 40 degrees. 40 is equal to 40, so the distance from B to C must be equal to the distance from E to C. Okay, so let's go to a few tricky examples. It says write and solve an inequality relating the possible values of X. Okay, this one's quite tricky. One of the first things I would do with this particular problem is I would find this angle first. So that's going to be 180 minus 102 minus 27. Which is 51 degrees. Okay. So in this triangle right here, okay, I know, well, since this is 51 degrees, I know for sure that this side is the longest side, okay? In this triangle right here, have that 110 degrees. Well, it's not possible for either of these angles to be greater than 110, so this is going to be the longer side. So one of the things that I know is that this side right here is shorter than that side. This side right here is shorter than this side, and this side right here is longer than this side because this is the longest side for sure. So therefore, I know that 3x plus 2 side is bigger than the x plus 3 side. Okay, has to be, because this is the longest side of one triangle and it's a shorter side of this one right here, because it's not possible for this angle to be greater than 110 because the angles in a triangle add up to 180. So I'm just going to go through and solve this inequality. So this is going to be 2x plus 2 is greater than 3. 2x is greater than 1. X is greater than 1/2. And there we go. All right. My x value just has to be bigger than 1/2. All right. So this next one, it says list the sides of PQR from least to greatest. Unfortunately, you're not given the sides, you're given all of the angles. So PQR. And so what you need to do is you need to find the measures of the angles. So one thing that you should know is the sum of the measures of the angles of a triangle is 180. So we have 4n plus 61 plus 67 minus 3n plus n plus 74 is equal to 180. Which is 202. So that's going to be 2n plus 202, because I divide my like terms, okay, plus 202 is equal to 180. And subtract 202, subtract 202. 2n is equal to negative 22. Divide by 2, divide by 2. N is equal to negative 11. Now, normally you cannot have a negative measurement, but when I substitute this in, that might change things. So now I find my angle. So my first angle is going to be 4 times negative 11 plus 61, which is negative 44 plus 61, which is 17 degrees. So the measure of angle P is 17 degrees. Okay, the measure of angle Q is 67 minus 3 times negative 11, which is 67 plus 33, which is the measure of angle Q is equal to 100 degrees. And last one is going to be the measure of angle R is equal to negative 11 plus 74, which is 63 degrees. And you'll see if you add these up, you do get to 180. So it says order it from least to greatest. Well, 17 degrees is my smallest angle, so my smallest side must be QR. Then 63 is my next biggest, so PQ must be my next biggest angle. And the last one is its opposite, angle Q, so which is PR, so PR. And things that you'll notice are, of course, your angle. The letter of your angle is going to be, your side is not going to have that letter, so that's one of the observations.